So here all we were having a stream concept in previous video. Now we discuss about the stream data model and architecture. In this video, we will try to collect the information about the stream computing and standard. How the stream computing is initiated with the help of the sampling data. Okay, let's go ahead. Uh, we have gone through this string data model, you know, stream data management, and have an example of this. Three examples: sensor data, image data, and internet and web traffic. We have understand what really the stream queries is all about. We understand what are the issues in the stream processing. Now, next thing and most important thing is how the sampling data, how we sample data in a data stream. And we need to get a perspective regarding our topic of sampling data in data stream to help, which help us in the stream computation. Okay. Let's move ahead. What really the thing of what really the sampling data in the stream is all about. So in this book, what we are referring, when we call upon managing data streams, sometimes we think to get a reliable samples from a stream. As with many stream algorithms, the trick involves using hashing in somewhat unusual way. Okay. Now, what really the thing is to be how the thing is to be take care. Okay. So, motivating examples are the below one. Like I'm going to read and let you explain about this. The general problem we shall address is selecting a subset of the stream so that we can ask queries about the selecting subset. Ask queries important and have the answers be statistically representative the whole as a stream. Now the thing is, we are going to select a subset of this stream, not the whole stream first. This is our first condition actually. We're going to select. We are going to select a subset of a stream. Okay. So that we can ask queries about the selected subset and have the answer be statistically representatives of a stream as a whole. Okay. So first of all, we are going to select a subset, then we select a subset, and this subset will be statistically processed and which will represent the whole stream. That is what overall an idea in managing the thing is. Okay. Now, if you know what queries have to be asked, then there are a number of methods that might work. But we're looking for a technique that will allow ad hoc queries on a sample. Okay. So in the previous, we got an idea about how the subset will be selected and the queries will be asked in the subset, and the answer will statistically represent the whole. Here we are asking about the ad hoc queries as a sample. Okay. Here we are asking about the ad hoc queries as a sample. So we shall look at the particular problem for which the general idea will emerge. Okay, so the running example is the following. The search engine receives a stream of queries and would like to study the behavior of the typical users. Okay, we assume the stream consists of tuple user query time. So we are just replicating the sample concept in this example. You know, a search engine is giving a stream of queries, but it would like to study the behavior of typical users. Okay, that's why the stream, from the stream, which consists of the tuples, we are targeting what the user and user query and time. This is a tuple which will help to understand the query as a whole. And suppose that we want to answer queries as what fraction of the typical users queries were repeated over the past month, repeated over the past month. So assume that we will just store the 1/10th of the stream elements. Now this is a sample actually. We are not pushing all the elements within our database. We are just pushing 1/10th of the whole stream. So obvious approach to generate a number is to say as an integer is 0 to 9. So that 10th, first of all, in the full section of the 100, we are only taking the 10, and which is represented as the 0 to 9 as the response to the search query. Now store the tuple if and only if the random number is 0. If we do, each user has an average of 1/10th of their queries stored. So how the each user's queries will be stored, and only 1/10th of the each user queries will be stored according to the given problem. So how will it be? If the random number is 0, matlab there is no there is no any query regarding this. What right now user is asking, isn't it? That will be stored as the 0. So statistically fluctuating will introduce some noise into the data. But if users issue many queries, the law of large number will assure us that most users will have a fraction close to 1/10th of their queries stored. So we will have fractions 1/10th of their queries stored. Now, however, this is give us the wrong answer to the query asking for average number of the duplicate queries for the users. Okay. Suppose a user has issued the S search queries one time in the past month, T search queries twice, and no search queries more than twice. So if we have a 1/10 sample, this is a we are analyzing the fact. If we have 1/10 sample of the queries, we will see the sample that the user has expected S/10. So we have S queries of one time past month, S/10 of the search queries issued once, and 2 times he has searched for T. So of the D switches twice, only D/100 will be appeared twice in the sample. That fraction D's time probability of both occurrence of the query will be 1/10th of the sample. So of the queries that appear twice in the full stream, 18D/100 will appear exactly once. See why note that 18/100 is the probability that one of the two occurrence will be in the 1/10th of the stream that is selected. And the other is 9/10th that is not selected. Correct answer is the query of the fraction of the repeated searches is D by S plus T. Okay, D is the something which is happening twice, and S is this. S is the numbers of the queries which is happening once, which is adding it the number of queries passed per second. However, the answer which I have obtained from the sample is D/100 S plus 19. We have latter formula. Note that D/100 appear twice, was S/10 plus 18 D/100 appear once. Thus, the fraction appearing twice in the sample is D/100 divided by D/100, S/10, and 18 D/100. This ratio is D/10 S plus T for no positive values. S and T is D S plus T, and D is equal to D 10s plus 90. This is the formula somewhat we have experience after detecting that. To understand this, we have taken in a query, and if a query is asked only once in a sample of 100, then it will be denoted as S, and if it's query asked for 2, it is denoted as D here. Now we try to get a query fraction in searches. This D by S plus T formula will drive, and with our notification, we came across that of all the queries, if it appears full, we assume that how many times the two queries will be asked in the 100 sample space. It is 18T. So with the probability principle, we get an answer of 18/100 without two occurrences. For the one occurrence, we have 1 by 10, while the other will be 9 by 10. So that part has been here has been designed as the dy10s plus 19d. Finally, we when we drive the formula twice due to the 100 consideration, we will get in the formula like d s by 10 plus 18d by 100. So this is how we are getting the formula to calculate of the sample streams, and we deduce the formula with the help of the algebraic summations. So when we obtain a representatives for a sample, and we work like this, uh, you know, we understand how this sample queries has been come to the d by 10d plus 19d. So many other queries about the statistics of typical users cannot be answered by taking a sample of each searched queries. Thus, we must strive to pick up 1 by 10th of the user and take all the searches for the sample. By taking none of the searches from the user, if we can store a list of all users, whether or not they are in the sample, then we could do the following. Each time a search query arrives in a stream, we look up the user to see whether or not they are in the sample. So if so, we add this search and query to sample. If not, then however, we have no record of ever seeing this user before. Then we generate a random integer between 0 to 9. If the number is 0, then we add this user to our list and value in. And if the number is other than 0, then we add the user the value out. Okay. That method works as long as we can afford to keep the list of all users in and out decisions in the main memory. Because there is no time to go to this for every search that arrives. By using a hash function, one can avoid keeping the list of users. That is, we have hash each user name to be 10 buckets 0 through 9. So if we uses hash of the 0, then accept the search query for the sample, and if not, then not. What is it? It is saying this particular explanation is helping us to drive. Actually, it is helping us to drive that we are taking a 1 by 10th user. So we will have a sample. We will have a bucket of the 0 to 9. So when new user will come into the system, then we will give it the 0 space, and it will be the in the memory, and then other random numbers will be denoted as the out. So with this with the functionality of the in and out, we're trying to derive every search around the disk by using our hash function. So we can avoid keeping list of the users. Okay, 0 through 9. If the user hashes to the bucket 0, then accept this search query for the sample. If not, then not. So now we do not actually store the user in the bucket. In fact, there is no data in the bucket at all. Effectively, we use the hash function as a random number generator with the important property that when applied to the same user several times, we also get the same random number. That is, without storing in and out decisions for any user, we can reach the constructed decision anytime when a search query by the user arrives. More generally, we can obtain a sample consisting of the rational function a by b. The user of the hashing will be b bucket. Okay, 0 through b minus 1. And at the search query sample is which the hash value is less than a. Okay, this is in general formula of sample spaces, or how which sample spaces will arrive. Just put our example. So 1 by 10. So A will be 1 and B is 10 here, then B buckets, and then it is meaning to say that 10 buckets. Then 0 through B minus 1. Then it is 0 to 9. And then we add the search query to the sample if the hash value is less than A. So what is A here is 1. So less than A is 0. So if the random number generates 0 number, then it will be added in the search query and it will be in the main. But if it is not, then we don't add in the search query. That's it. This is a general formula. What is we got an explanation regarding the sampling in the data streams. Okay. Now let's move for the general sampling problem. Or really the general sampling problem. It depends upon the size as well, how we, which size we understand of the sampling problems. So the running example is typical of the following general problem. Our stream consists of a tuple of n components. A subset of the component are the key components on which the selection of the sample will be based. In our running example, there are three components: user, query, and time, of which only user is the key. Here we could also take a sample of queries by making a query be the key, or even taking a sample user query fails by making both those components form the, that is the key we are getting derived by the bucket list of 0 to 9 in the previous example. To take a sample space of the size A by B, we have hash key value of the tuple to B buckets that we have understood in the previous general analogy would be. And accept the tuple of the sample if the hash value is less than A, that is 0. If the key consists of the more than one component, the hash function need to be combined the values of those components to make a single hash value. The result will be sample consisting of the all tuple of the certain keys. So the key selected values will approximate by B of what is appear in the string. That is again an explanation of this fact what really we got in general. Okay. Next is how do we go for the varying size. And now the sample is of the fixed size. We select the 10 sample is based on the 10 size and we act accordingly. What if the sample size is very much different? So often the sample will grow as more of the stream enters the system. In our running example, we retain all the search queries, the selected one by 10th of the user forever. As time goes on, more searches for the same user will be accumulated. And new users that are selected for the samples will appear in the stream. Now, if you have a budget for how many tuples for the stream can be stored as a sample, then the fraction of the keys values must vary, lowering as time goes on. In order to assure that at all times the sample consists of the tuple from a subset of the key values, we choose the hash function h from the key values to vary large number of 0 to 1 to be minus 1. What we understand. We maintain a threshold t, which initially can be largest bucket b minus 1. At all times, the sample consists of those tuples whose key k satisfies hk is less than equal to t. New tuples from the stream are added to the sample if and only if they satisfy the same condition. If the number of the stored tuples of the sample exceeds the allotted space, we lower to the t to t minus 1 and remove all the sample, all those tuples whose key k hashes to t. But for efficiency, we can lower t by more than 1 and remove the tuples with the several highest hash values whenever we need to throw some key values out of the sample. Further, it is obtained by the maintaining an index on the hash value, so we can find the tuple whose key has to be particular value quickly. Actually, we are just analyzing the previous thing. Okay, we are just making a hash function out here from the a very large amount of tuple sets, and we try to maintain a whole threshold value. If the if those if the threshold value is satisfied, then the streams are added, and if it doesn't satisfy, then the streams are not added. It's as simple as that. That's what a varying sample size is taking care. Okay. Like in this example, we have a stream tuples like university, course ID, student ID, and grades. Okay. So assuming the university are unique, but the course ID is unique only with the university. Different university may have a different course with the same ID, like CS 101. Likewise, the student IDs are unique only within a university. Different university may assign same IDs for the different students. Suppose we want to answer certain queries approximately 1/20 of the sample of the data. Okay. So for each queries below indicate how you construct the sample. Then what the key attributes should be. For each university, estimate average number of students in the course. Estimate the fraction of the student who have a CGPA 3.5 per month. Estimate the fraction of courses with at least half the student got A. Like this, we can push the thing. Our sample is placed, and the sampling will be done. The sampling will be done according to the two way. One is the fixed way, second is the general way. Process is same. We select our stream structure of a sample of a selection, and we put the formula ready. If it's even if we for A is 1 and B is 10, then we have to formula 1 by 10. And then we have a 10 bucket set, and the hash function. And hash function is always less than equal to A, which will be added in our query section. Okay, in general, this is what the thing is all about. In the previous section, we have a maintain a value A. Here, in when we have a varying sample size, then we are fixing this thing as a threshold T. Like this, we go. This exercise can be done like this. We have a 1, 2, 3. Okay. Now the next topic in our syllabus is filtering streams. Okay, we have to understand what further sampling data in the stream has been done. Now we go for how the filtering stream will be done in this section. So the famous filter what we use in this filtering stream is the blue filter, and which is one of the most important point in our examination. Okay, so another common process on a stream is selection or filtering. We want to accept those tuples in the stream that meet a criteria. Accept tuples are passed to another process as a stream, while other tuples are dropped. The selection criteria is property of the tuple that can be calculated. Example, first component is less than 10. Then the selection is easy to use for harder. The criteria informs lookup for the membership set. It is especially hard and that when that set is too large to store in the main memory. In this section, we shall discuss the technique known as the blue filter as a way to eliminate most of the data. Okay, so actually we will learn this filtering stream on the next video. Thank you for your patience and learning. Okay, we will understand about the blue filter as well. Thank you.